Welcome to A-Star Science. This is one of our videos as part of our GCSE Must Know Chemistry series. Today we're going to be talking about chromatography, and chromatography is a form of qualitative analysis. So qualitative analysis refers to analysis about the identity of a substance in chemistry. That differs, of course, from quantitative analysis, which refers to the amount of a substance. So qualitative analysis is things like chromatography, which we're doing now, testing for gases, things along those lines where we can look at the identity of a substance. And quantitative analysis is where we use things like relative formula mass and moles to find out the amounts of a substance in chemistry. Both of them are important. So today we're talking about chromatography, and we can look at the root of the word chroma. So chroma means color, okay? And tography has the word graph in it. So tography means map, okay? So like a picture map. And so we're going to use chromatography as a way to identify the different parts of a mixture by separating them based on their colors. So it's a really useful experiment, a useful technique by which mixtures can be separated. And that's what chromatography is. It's a separation of mixtures. There are two types. There's paper chromatography, and there is gas. There are more than that, but for GCSE, you just need to know about these two. Paper chromatography is very cheap. That's an advantage. Okay. And but it's not very accurate. It's also easy to do, but it takes a long time. Not too long, but it's not instant. Now, gas chromatography, on the other hand, is expensive, but it's very accurate and very sensitive. And that's what you'll see used, for example, in crime labs, forensic science labs. They will use different forms of gas chromatography along with other qualitative techniques. So it's expensive, it's very accurate. It's not easy to do. You need to be trained to do gas chromatography, okay? But if you do manage to do it, the results can be very, very accurate. You can determine exactly what type of substances you have. So we're going to look first, we're going to look at paper chromatography in this particular case, because that's what you'll be doing in your GCSE required practical. So the basic setup is if you have a beaker, like so, and in that beaker, you'll normally have a solvent. In this case, we're going to use water. Now, a solvent is something that a solute can dissolve in, and we call that the mobile phase. The solvent is the mobile phase. Mobile means it can move. And in that particular beaker, you have some filter paper or chromatography paper, and it will have a line drawn on it in pencil, has to be done in pencil, and you'll put a color, sample of a ink or dye or whatever it is you want to test, and you will then watch as the solvent rises up that paper like so. Okay, so the paper we call the stationary phase. Stationary means still, it doesn't move. So the solvent is the mobile phase, it moves up the paper, and the paper is the stationary phase. Now, if that ink contains different colors or different dyes, and they are soluble in that particular solvent, you may see a separation of colors. So for example, we have a purple ink that may separate out into red and into blue, for example. And this is how chromatography is carried out. Now, it's very important that the baseline, which is here, that pencil line, we call that the baseline, that must be drawn in pencil. And that's to ensure that there's no contamination between an ink line and the inks that you're sampling. So that must be drawn in pencil, because pencil is not soluble in the majority of solvents. And that's very important. The second key that they ask you about on the exam is that the baseline must be above the solvent. So you can see in this particular area here that the baseline is above the solvent. If it was below it, then that means the ink that you're trying to sample would just mix with the solvent at the bottom of the container. And that way you wouldn't actually get the separation of mixtures that you really want. Now, one key principle within chromatography is how can we distinguish between different colors that may separate out. And we do that with what we call the RF factor. RF meaning retention factor. And that is measured by the distance traveled by your color, your sample, divided by the distance traveled by the solvent. So for example, in our case, the solvent went all the way up to this line here, as you can see where the arrow is. And the inks, the red ink only traveled from the baseline to there, and the blue ink traveled from the baseline to here. And you would use those values, the red ink or the blue ink, and you divide that by the distance traveled by the solvent. Okay? And you will always get a number less than 0. Sorry, less than 1, excuse me. So you always get a number less than 1. So it will always be a decimal number, because the distance traveled by the sample will always be smaller than the distance traveled by the solvent. So this is a very, very important technique. Now let's look at why chromatography actually works. The key to why it works is that the colors will separate because some solutes, meaning those things that are dissolved, will be more attracted and more soluble in the solvent. So for example, in our case, the blue mixture here, the blue portion of the mixture is much more soluble, and so rises much quicker and easier with the solvent front as it travels up. Whereas the red mixture is not as soluble, is not as attracted, and so it doesn't rise as much as the blue mixture. And in this way, you can compare the RF values of different colors, even though they may look similar, they may have different RF values. Now let's look at an example. So let's look at a chromatogram to see how we can do an analysis from what you might see in an exam question. A chromatogram is the picture that you're left with afterwards after you do a chromatography experiment. So one of the first questions we can ask, or you might be asked in an exam, is which one is a mixture and which one is pure? Well, we know that number 1 and 3 are mixtures. Those are mixtures. Why? Because they have more than one color present. Number 1 has 2 colors. Number 3 has separated into 2 colors as well. So that means it's a mixture. We don't know if number 2 is pure, because number 2, a question you may be asked is, which one is not soluble in the solvent in the mobile phase? And that would be number 2. That's because nothing has happened. It hasn't separated out. It may be pure, you never know, but it hasn't separated out into different colors. So we're going to say that that one is not soluble. It appears to be pure because only one color is remaining, but we don't really know because it hasn't separated out. The second question is, you can ask which one has the same dyes present, the same colors present, and that's clearly number 1 and number 3. So even though number 1 appears purple and number 3 appears green, they both contain that blue color. Now, the reason we know that is not just because of the actual color, excuse me, the actual color, but also where they're located. They're both located at the same point. That means that they will be the same distance, have the same RF factor as each other. That means they're going to be the same dye. You may also be asked which ones have different dyes present, different colors present. And we can see while 1 and 3 had the same color blue, they also have different dyes present. In this case, 1 has a red color and 3 has an orangey color. They look similar, but they are different. They have a different look, but they also have a different RF value. And so those two are definitely mixtures containing different colors. Number 1 is made up of 2 different colors, and number 3 is made up of also of 2 different colors. So this is a simple exam style question that you may be asked. Which one's a mixture versus which one is pure? How do we know which one is soluble or not? It hasn't moved. Number 2 hasn't moved up the paper. Which ones have the same dyes, 1 and 3, because they have the same RF value. Chromatography is a relatively simple topic, and I hope this video has helped you to understand it more. Please make sure you like and subscribe. Leave a comment if you'd like me to do any specific video for your GCSE chemistry.